What's going on, everyone? Homework assignment 26. Today's objective, I can write equations of parallel lines. So we're gonna use our knowledge of equations of lines, and we're gonna go ahead and take a look at how to create equations of parallel lines. We'll go over the definition of what parallel means as well. So parallel lines, as we know them, are two lines in the same plane that never intersect. And the big thing to remember here is that parallel lines have the same slope, okay? Parallel lines have the same slope. So let's say if we took the equations of these two lines. So this equation here, I'll call it my first equation, and then I'll use my second equation. So this first equation has the line would be y is equal to, let's see, it looks like the slope is 2 here. So y is equal to 1, 2 over 1, 2x plus 4, and our other equation, y is equal to 2x, it looks like a minus 1. All right. So notice these two equations. Both different equations. I'm saying that these equations are parallel, and I can tell because their slopes are exactly the same. Both have a slope of 2. They both have different y-intercepts. I know that these lines are never going to touch. That's the biggie that we're going to have to know about parallel lines and their slopes. The slopes of parallel lines are the same. So let's go to an example to figure out what are we going to do to solve these problems. Before that, let's take a look at some steps. So when we're writing equations with parallel lines, writing equations with parallel slopes given an equation and a coordinate. So same slopes given an equation and a coordinate. So step one is we're going to convert the equation to slope-intercept form, and I'm going to put my little if necessary next to it. All right, so that's only if it is necessary. Some of them are already in slope-intercept form, in which case we don't have to. Step two, we're going to write a new equation in slope-intercept form with the same slope since it's parallel, and substitute the x and y coordinate, writing b as the y-intercept. 3, we're going to solve for b. 4, we're going to write the new equation. So we'll go through each step and what exactly it means. So let's start with this equation. So we're going to write the equation of a line that passes through the given point and is parallel to the given line. So the point that we have is 5, negative 4. So we want our line to go through that point, and we want it to have the same slope as this equation right here. So here's what we'll do. It's already in slope-intercept form, so I don't have to worry about that. So I'm going to work on rewriting a new equation. Remember, I want my equation to be in slope-intercept form. Plus b. So what I'm going to do is I'm going to label these coordinates. I know x. I know y. I know what my slope is going to be. I don't know what my y-intercept is going to be. So I know that my x-coordinate is 5. I know that my y-coordinate is negative 4. And if we're saying that I want the line to be parallel to this line, then that means that its slope must be the same. So let's substitute the values. So negative 4 is going to be equal to 1/5 times 5 plus b. Just like we've done before, algebraically finding equations of lines. Finding our b value and then rewriting our equation. So let's go. So negative 4 is equal to 1/5 times 5 is 1 plus b. Finally, it's a one-step equation. Subtract 1 from both sides. We have negative 5 is equal to b. Let's rewrite our new equation. We solved for b, and our new equation is going to be y is equal to 1/5 x minus 5. So this is an equation that is that has a slope of 1/5, so a parallel slope, different y-intercept. And if we wanted to check it, what we can do is we can take this coordinate, so 5 and negative 4, substitute 5 for x, substitute negative 4 for y, and we'll find out that it does in fact fit our equation. Second example, notice that this one is not in slope-intercept form, so the first thing that I'm going to do is get it to slope-intercept form. So I know that I could subtract 3x from both sides. I'm left with negative y, remember that that negative sign comes with it, is equal to 5 minus 3x. Let's get it to slope-intercept form. I don't want to know what negative y is. So that's going to be y is equal to negative 5 plus 3x. Negative 3x divided by negative 1 is a positive 3x. Let's rewrite it. So y is equal to 3x minus 5. All right. Let me take all of this. Let's shrink it down and let's move it over. All right, so that's the equation of my line. Okay, so that's the equation that I'm using. So I want to find the equation of a line that passes through 2, 7, and that is parallel to this equation, which we know is this equation. So we know it has to have the same slope. So same thing. I'm going to identify my x, my y, my slope. I don't know my y-intercept yet. So 2, 7. I know that my slope needs to be parallel, so it needs to be the same. So we can see right here that my slope is going to be 3. And finally, the question mark. Some people might be asking at this point, why is it that I can't just take the 3 knowing that this is 3x? We can't guarantee that it's going to be 3x. It worked out in this case that it turned out to be 3, and that's just that's just a coincidence that it worked there. But if our y had a different coefficient, then we would be dividing, and it wouldn't necessarily be a 3. Maybe it's going to be some other value, a 3 divided by some other value. We'll see an example of that later. All right, so let's go ahead. Let's input into our slope-intercept form equation. So it'll be 7 is equal to 3 times 2 plus b. All right, so it's going to be 7 is equal to 3 times 2 is 6 plus b. Subtract 6 from both sides. 1 is equal to b. So if I rewrite my equation, that goes through the line, the point 2, 7, and has a slope similar to my equation above, it's going to be y is equal to 3x, because my slopes are the same, plus 1. And again, same thing, you could check by substituting the coordinates in for x and y, and you'll find out that it's true. Next example, I like this one. So if we think about exactly what's going on here, this one actually not so bad. So again, write an equation that is similar. So we know something about this line. So y is equal to negative 4. We know that means that it has a slope of 0. Okay, it's got a slope of 0. It's a horizontal line. All right. So I look at the coordinate negative 3, 2, and I can kind of already have an idea of what my line is going to be, but we'll still do the same work. So let's go ahead. It's already in slope-intercept form because I don't have a slope, so my y-intercept is right there. I do have a slope, actually. It's 0. I don't want to say I don't have a slope. So my x is negative 3. My y is 2. My slope I know is 0. And my y-intercept, I don't know what, I guess I do know what it's going to be, but I guess I'll put a question mark anyway. All right, so just to show us. So we can say 2 is equal to negative 3 times 0 plus b. All right, so 2 is going to be equal to 0 plus b, or another way to say it, whoopsies, is that 2 equals b. Therefore, if I was to rewrite my equation, initially it would be y is equal to 0x plus 2, but we know that would just turn into y is equal to 2, which is another horizontal line. All right, that one doesn't really make too much sense. Bring the questions to class. Last one. So again, not in slope-intercept form, but we could put it in slope-intercept form to start. So I'm going to subtract 2x from both sides. I'll have 3y is equal to 18 minus 2x. And this kind of brings up the point that I mentioned before. Divide 3 by both sides. We'll have y is equal to 6 minus 2 thirds x. Rewrite it. We'll have y is equal to negative 2 thirds x plus 6. All right, I'm going to take all of this, shrink it down, and I'm going to move it over here. All right, I have my equation in slope-intercept form. I know that the slope is negative 2 thirds, so I want a line that goes through 6, 4 and has a slope of negative 2 thirds. So x is 6, y is 4, m is negative 2/3, and b, I have no idea yet. We'll find it. All right, so then we have 4 is equal to m, which is negative 2/3, times x, which is 6, plus b. So 4 is equal to negative 2/3 times 6 is negative 12/3, which is going to be negative 4, plus b. I know that I can add 4 to both sides. Therefore, b is going to be equal to 8. So my equation that goes through 6, 4, that has the same slope, is going to be y is equal to negative 2/3 x plus 8. All right, there it is. Get these notes down. Take a look at the practice problems. Try them out. Practice them. Come to class. Ready to go. I'll see y'all tomorrow.